Hi all, thanks for tuning in again. In this presentation, I will explore the technical solutions element of the Connecting Nature framework in a bit more detail. Just in case you haven't watched the introductory presentation, I'm Stuart Connop and I work at the Sustainability Research Institute, which is part of the University of East London in the UK. I am currently working on the European Commission funded Horizon 2020 project Connecting Nature, in which I'm working with three frontrunner cities, Genk, Glasgow and Poznan, to help them mainstream and scale nature-based solution implementation. In order to support these scaling processes, we've developed a supporting framework which I introduced in the previous presentation. Here, I will explore the structure of the technical solutions element of the framework in more detail. The technical solutions element was designed to support stakeholders, in particular local authority teams, in navigating the complexities of the planning, delivery and stewardship stages of scaled technical solution implementation. The support is structured in a series of guiding questions to stimulate the right thinking and processes to guide you in implementing the technical aspects of nature-based solution scaling. The steps are: Step 1, define the nature-based solution. Step 2, develop an understanding of the landscape context and ecosystem service needs. Step 3, embedding multiple functions into the planning, delivery and stewardship of the nature-based solution. Step 4, monitoring and evaluation of technical performance. And Step 5, build an evidence base to promote nature-based solutions to a wider catchment. So, the first step is defining your nature-based solution. This does not need to be a detailed plan at this stage, just the basics of what you know. For example, where you're considering implementing a nature-based solution. Over what scale? Is there a particular type of intervention you want to scale? In the previous presentation, we explored the concept of what is a nature-based solution. The images here represent a variety of types and scales. In this step, we define what our general targets are for scaling in relation to types of NBS. In Step 2, we explore the landscape context and ecosystem service needs of the location into which the scaling is being planned. This comprises of two components. Firstly, defining the landscape context where the nature-based solution is being implemented, and secondly, defining the needs of place context of where the nature-based solution is being implemented. The first component, defining the landscape context, is a process for ensuring that biodiversity net gain is embedded into the nature-based solution. It involves developing a clear understanding of the location that the nature-based solution is being installed. For example, what is the underlying landscape at local, city and broader scales? What are the typical ecosystems and biodiversity? What restrictions does this put on the design? How can the technical design be linked to this context to avoid generic, industrially standardized solutions? And if the nature-based solution is at a large scale, how does the design reflect the changing landscape across this scale? This understanding can often be developed from existing documentation where this is available. For example, local biodiversity and green infrastructure strategies, or locally typical and suitable planting recommendations. In some locations, even more comprehensive supporting data might be available. For example, this London's Natural Signatures report that breaks London down into a series of signature areas based on underlying geology and local ecosystems. Where such data is not available, it might be possible to use local knowledge. For example, urban ecologists with local understanding, and record centres that store data on local species and habitats. If such local knowledge is not available or accessible, it might be necessary to develop new knowledge. Ideally, every city would develop their own natural signatures guide to help shape nature-based solution design. However, it's also important to supplement this higher level knowledge in relation to reading the landscape with site surveys and exploration of local ecology. The second component is defining the needs of place. This comprises developing a clear understanding of the needs of the place that the nature-based solution is being installed. This corresponds to developing understanding of the social, economic, and environmental needs associated with the locality and correlating these needs with the types of benefits that can be achieved through a nature-based solution approach. Again, this should be considered over different scales, from local needs through to city or even national strategic priorities. It can also be beneficial to define these needs in terms of a hierarchy of priorities. This can help with managing trade-offs during the planning, delivery, or stewardship phases. Potential mechanisms for achieving this are diverse and can include everything from top-down approaches such as strategic policy scans to bottom-up approaches like co-creation workshops with local residents and stakeholders, for example, using causal loop planning methods and promoting creative scenario thinking. Data from local authority departments, regional governmental organisations and non-governmental organisations can also be invaluable for this stage. We are encouraging cities to exploit as wide a range of resources as possible to develop a holistic overview of the priorities associated with the locality of the proposed nature-based solution. We are also promoting an approach that consolidates and shares the data collected through the use of dashboards that display spatial data that can be used to support decision-making for nature-based solutions. The added value of this approach is that the dashboards can also be used to support and showcase evaluation of the impacts of nature-based solutions following implementation. The dashboard in this image is a prototype being developed by Glasgow City Council. London's Green Infrastructure Focus Map represents a fully functioning example of this. This map provides the ability to select from a grid of 350-metre hexagons across London. Each grid space has attribute data on a series of social and environmental parameters associated with its location. For example, air quality, access to public green space, and flood risk. Such a tool enables an instant understanding of needs associated with the local context for informing the multifunctional design of nature-based solutions. By attributing a scale of need for each attribute, it also helps to prioritize potential benefits. Once a map such as this is created, it can be updated with new datasets and supplemented with the outcomes of co-creation workshops to help inform designs for nature-based solution multifunctionality. Step 3 involves bringing the ideas from Step 1 and the learning from Step 2 into the planning, delivery and stewardship of the nature-based solution. Once an understanding of the landscape context and a prioritized set of needs have been established for the location where a nature-based solution is planned, the next step is to integrate these into a multifunctional design. This includes considering how the design can deliver on the needs and landscape context, how trade-offs will be dealt with, how flexibility will be incorporated into the design to allow for changing needs, and how legacy management will ensure sustainable delivery of benefits. Now, obviously, this is a very simplified explanation, and there are numerous interrelated complexities involved in achieving this multifunctionality. For example, funding, governance, and stewardship challenges. But once there is a clear idea of the range of benefits you want to achieve through the multifunctionality of the nature-based solution, there are a diversity of resources that can help to finalize and realize the design. This includes direct support from industry, nature-based enterprises that design and implement nature-based solutions professionally, including connecting nature's very own Helix Pflanzen, research and information associations, case studies of good practice on OPLA, and project websites, including Connecting Nature's website, statutory guidance literature, and conservation evidence. So hopefully that gives you some inspiration in relation to the first sections of the technical solutions element, particularly in relation to developing a plan for the types of multifunctionality that can be achieved, deciding how this multifunctionality will be delivered through a technical design, and considering a multi-criteria approach to prioritizing benefits and co-benefits, and how this would feed into a cost-benefit approach for the finalized design. The next stage of the technical solutions element relates to transitioning from the planning to the delivery stage of implementation. The delivery stage technical solutions supporting questions promote good practice during nature-based solution delivery in terms of both evaluation of the broader impacts of the delivery, for example, considering any potential negative impacts of construction, and dealing with any potential loss of benefits between the planning and implementation stages, including dealing with any new trade-offs that emerge. The final series of guiding questions relate to the stewardship phase of nature-based solution implementation and scaling. This includes consideration of the technical legacy of the nature-based solution. For example, ensuring that there is a process in place for evaluating the technical performance of the nature-based solution. Is it continuing to deliver the targeted multifunctionality the nature-based solution was implemented to deliver? As this includes a focus on evaluation, this part of the technical solutions element aligns closely with that of the evaluation element of the framework. Here, the technical element promotes the use of information generated from the evaluation of nature-based solutions to inform adaptive management of the technical design of the nature-based solution, to ensure that targeted multifunctionality is sustained. This includes supporting decision-making in relation to whether the nature-based solution is performing as expected, and also whether there are environmental, economic, or social factors that are driving a need for change in relation to the benefits being delivered. In other words, considering whether the nature-based solution technical design or management might need to be adapted to address newly emerging challenges that were not foreseen or indeed relevant at the time of planning. Guiding questions in this section also support the use of this emerging knowledge and experience to feed into the technical aspects of unlocking broader buy-in and rollout of nature-based solutions. Using this approach, it is possible to not only ensure the legacy of scaled nature-based solutions through appropriate stewardship, but also to ensure that this legacy is adaptable to changing conditions and demands. So that was intended to provide you with a good introductory overview in relation to the technical solutions element of the Connecting Nature framework. If that is of interest, please do go to the Connecting Nature website, look at the guidebook, and explore the questions. Thanks for listening.